Module 3, Centralized Lighting Hardware. Fundamentals for centralized lighting. In traditional wiring, the circuit breaker is wired to the dimmer. The dimmer is then wired to the load. A separate switch or dimmer is required for each individually controlled load, which can result in a number of light switches in a single gang box. In centralized lighting, the circuit breaker is wired to a module in the centralized lighting panel. The dimmer module is then wired to the load. Single, multi-button keypads can control multiple loads or lighting scenes. For your customers, the main benefit for centralized lighting is a reduced number of light switches in each room. Centralized lighting is more robust and reliable and has failover control scenarios. However, it's limited to new construction or major remodels. The Control4 centralized lighting solution can be used for residential and commercial applications, accepts universal voltage from 100 volts to 277 volts. The modules are mounted using the DIN rail standard and are all network connected, and those centralized lighting loads can be controlled from any interface, a keypad, a touchscreen, the on-screen, or the Control4 apps. The system is designed within Composer Pro and have the same features as the regular lighting products. They can be used in advanced lighting to create lighting scenes and can be grouped in order to control multiple loads as a single load. The Control4 centralized lighting solution includes failover modes in case the system is offline. There are pre-programmed failover behaviors on the wired keypads, remote overrides from hidden switches, and local overrides on the modules themselves. This module has 3 sections: the lighting modules, terminal blocks, and panels. The Control4 modules include the 8-channel dimmer module, the 8-channel relay module, the 8-channel 0 to 10 volt module, and the 8-port network switch. The 8-channel dimmer module. The V1 dimmer module is rated for residential and commercial applications from 100 to 277 volts. The V2 adaptive phase and forward phase dimmer modules are rated for residential applications from only 100 to 120 volts. Be aware that neither the V1 nor the V2 modules are rated for use with multi-phase fixtures. The 8-channel dimmer module can control 8 individual loads. A load could be a single fixture or a row of connected fixtures. The 8-channel dimmer module comes in 2 different models. The adaptive phase dimmer module is auto-adaptive, detecting the load and selecting reverse or forward phase automatically. Reverse or forward phase can also be set manually if needed. The adaptive phase dimmer module can handle all load types: incandescent, halogen, magnetic low voltage, phase-cut dimmable fluorescents, phase-cut dimmable CFLs, and phase-cut dimmable LEDs. The forward phase module only does forward phase dimming and only works with magnetic core transformers and can handle incandescent, magnetic low voltage, and halogen. For either module, the load wattage depends on voltage, 100, 240, up to 277. The module is Ethernet connected, and the loads are controlled by keypads. The dimmer module accepts 2 20-amp lines in, maximum, from a circuit breaker. For 120 volts, both lines in must be on the same phase. Each line in powers 4 loads. Line 1 powers loads 1 through 4, and line 2 powers loads 5 through 8. If the maximum wattage is not exceeded, one line from a circuit breaker can be used for all 8 loads. A jumper must be used connecting line 1 and line 2. Line 1 in powers the module and must always be used. Here are the maximum wattages for the Control4 dimmer module. At 120 volts, in a Control4 cabinet, the maximum with one line is 1,920 watts. There is a maximum of 1,000 watts per single channel, and if connected to a non-dimmable load has a 500 watt maximum per single channel. Those numbers double if used with 240 volts, and those numbers remain the same for 100 and 240 volts if used in a non-Control4 unvented DIN rail cabinet. However, if used with two lines at 120 volts each, the maximum is 3,200 watts. There is a maximum wattage of 1,920 watts per line. Again, those numbers double if used with 240 volts. Notice that if they are used in a non-Control4 unvented DIN rail cabinet, there is a decrease in the maximum wattage due to the potential for overheating. However, arc fault breakers have a 1,000 watt maximum due to their nuisance tripping, which is a 2,000 watt maximum if used at 240. Be aware of the circuit breakers used in the installation. If the maximum wattage is not correctly calculated, the arc fault breakers will trip regularly, powering down the module and cutting power to all of the connected fixtures. Either module can also be used for non-dimmable loads. There is a forced preset level of 100% and forced ramp rate of 0 seconds. The minimum on is also set to 100%. There is a lower rating per load of 500 watts or 1/2 horsepower. Out of the box, all channels default to this mode. Dimmer properties are later set in Composer. The Control4 dimmer module has 8 channel buttons, which are accessible when the panel door is closed. Each button controls the respective load. Pressing the button goes to the preset level. Pressing and holding the button would ramp the load up or down. In a fault state, press and hold the button, which will reset any fault state. The 8-channel LEDs indicate the on or off state. The LEDs light up blue for on and black for off. The LEDs also indicate a fault state. The LEDs will turn red for a short circuit. The dimmer module includes an override button, which is also accessible when the panel door is closed. This button functions as an override scene for the whole module. After the loads have been individually set to their desired levels, press and hold the override button to save a module scene. The button can be pressed to toggle that module scene. The module override LED indicates power to the module itself. The LED lights up blue for on and black for off. It also indicates any fault state for the module itself. If the module override LED lights up red, there's a thermal overload. The module is overheating. The link activity LED indicates network connection and network activity. If the LED is green, the module is network connected, and if the LED is orange, there is activity on the network through the module. There is a recessed reset button. If that button is pressed, the module will reboot. If the button is pressed and held, it will reset the module to factory defaults. There is an auxiliary terminal that can be used for failover modes. This failover does not require a Control4 controller, a router, or even a network connection. This terminal is wired to a hidden, normal, dumb toggle light switch. That light switch would toggle the module scene that was saved with the module override button. That scene can also be created in Composer. In a failover scenario, where the network or the Control4 system were down, the end user could go to that hidden switch in the pantry, in the master closet, and still be able to control a scene from this module. On the other side of the dimmer module is the Ethernet port for network connection. Note that the V1 modules only have a single network in. The V2 modules include a network in and a network out that can be used to daisy chain the modules. Fundamentals on phases. Each fuse box has 2 service lines from the power company. Each line is 120 volts for a total of 240. This circuit breaker is a 120 volt single pole circuit breaker, which is usually used for outlets, lights, and most other electronic devices. This circuit breaker is a 220 volt double pole circuit breaker used for heavier electronic devices, such as dryers, refrigerators, ovens, etc. The 2 service lines coming into the fuse box run on different phases. The sine waves for those phases are opposite each other, heading in opposite directions at the zero cross. Service line 1 goes to every other circuit breaker in the fuse box. Service line 2, shown in red, is on the other phase and goes to the remaining circuit breakers. As you can see, Phase 1 and Phase 2 are staggered between all of the circuit breakers. When connecting a dimmer module to a fuse box, lines 1 and 2 need to be connected to the same phase. If they are connected to different phases, the lights could flicker, and other detrimental side effects could include white noise on your TVs and poorly functioning electronic devices. Coordinate with the electrician to ensure proper design and connections to the module. The 8-channel relay module. Like the dimmer module, the 8-channel relay module can be used from 100 to 277 volts at 50 or 60 Hz. It can control 8 independently controlled loads. However, these loads can only be turned on or off. The load wattage depends on the voltage, 100, 240, or 277. The module is Ethernet connected, and those loads are controlled by keypads. 4 20-amp lines in maximum come in from the circuit breaker. For 120 volts, all 4 lines must be on the same phase. Each line in powers 2 loads. Line 1 powers loads 1 and 2. Line 2 powers loads 3 and 4. Line 3 powers loads 5 and 6. Line 4 powers loads 7 and 8. The relay module features high inrush relays, capable of handling banks of fluorescent lights, non-dimmable LEDs, landscape transformers, motors, humps, outlets, etc. At 120 volts, there is a 64 amp maximum per module. Each channel has a 16 amp 1 horsepower maximum, and at 240 volts, there is a 2 horsepower maximum. Like the dimmer module, the Control 4 relay module features 8 channel buttons that are accessible when the panel door is closed and controls each respective load. Pressing the button will toggle the load. In a fault state, the button can be pressed and held to reset any fault. The 8-channel LEDs indicate the on or off state. The LEDs light up blue for on and black for off. The LEDs also indicate a fault state. The LEDs will turn red for a short circuit. There is a module override button accessible when the panel door is closed, which functions as an override scene for the whole module. After the loads have been set to their desired state, press and hold the module override button to save a module scene. Pressing the module override button will toggle that module scene. The module override LED will light up blue to indicate that the module is powered on, or black if the module is powered off. In a fault state, the module override LED will turn red to indicate a thermal overload for the module itself. The link activity LED will light up green if the module is network connected, and orange if there is network activity to the module. There is a recessed reset button that can be pressed to reboot the module, or if the button is pressed and held, will reset the module to factory defaults. Again, there is an auxiliary terminal which functions as a failover. It does not require a Control 4 controller, a router, or even a network connection. The auxiliary terminal is wired to a hidden, normal, dumb, toggle light switch. This light switch can be hidden in a pantry, at the back of a closet, or any other out-of-place location to enable the end user to execute the module override scene. That light switch will toggle the override scene, which can also be created through Composer. On the other side of the module is the Ethernet port. Note that the V1 modules only have a single network in. The V2 modules include a network in and a network out that can be used to daisy chain the modules. Fundamentals for 0 to 10 volt dimming. 0 to 10 volt dimming is commonly used for fixtures using fluorescent ballasts and can also be used with fixtures using LED drivers. It uses an analog, low-voltage control. The ballast or driver interprets the commands and performs the actual dimming of the load. When installing 0 to 10 volt dimming, the sink is the ballast or the driver in the fixture, and the source is the control device. However, that naming convention is not always followed by the manufacturers and can affect the number of loads controlled by the module. Sinks usually require 100 milliamps for control. Sources usually require 25 milliamps for control. The standard calls for 0 to 10 volts for control, where the 0 volt command is the minimum on level and each 1 volt increment equals 10% dimming, where 2 volts would be 20%, 3 volts 30%, 5 volts 50% on. However, that standard is not widely adopted nor followed. 3 other standards exist: 1 to 10 volts, 10 to 1, and 10 to 0. 0 to 10 volt dimming generally does not include on or off controls. A separate control is usually required. The 0 volt command is the minimum on level, such as 1%. It is not the off command. 0 to 10 volt dimming requires that you switch off the line voltage to the load in order to control the on and off states. This usually requires an external relay. In contrast to fluorescent ballasts, LED drivers usually do have an on and off control. A high voltage line in powers the module, and high voltage into the fixture powers the LED driver and the actual load. Low voltage commands from the module to the driver control the brightness of the load. And with LED drivers, full off commands are generally included. If the driver or ballast does not have an off command, a relay module can switch the on-off power to the ballast or the driver. The advantages for using the Control4 relay module in conjunction with the 0 to 10 volt module are simplified wiring and that it provides energy usage of the load. However, the disadvantage is that 2 separate modules are required for the fixture: the relay module for on-off control and the 0 to 10 volt module for the dimming. Or another option would be to use an external relay, which can be used with the Control4 0 to 10 volt module's relay outs in order to switch power on and off to the ballast or driver. The advantages for an external relay are lower cost and that it functions without a Control4 controller. However, additional design is required to spec out a location for these relays, and additional wiring and connections are required. The main disadvantage for an external relay is that they can be forgotten. If external relays are not installed and wired, the fixtures can never be turned off. Once the sheetrock is up, installing an external relay between the 0 to 10 volt module and the fixture itself can be difficult. The 8-channel 0 to 10 volt dimmer module works from 100 to 277 volts at 50 or 60 Hz and controls 8 loads. It can be used for fixtures using fluorescent ballasts or LED drivers. It can provide 100 milliamps per sink, which is approximately 50 per ballast, or 25 milliamps per source, which is approximately 12 per ballast. The module is Ethernet connected, and those loads are controlled by keypads. Knowing the naming convention is important in order to determine how many ballast or fixtures can be connected and controlled. The dimmer module can control the sink or the source. The sink is generally the ballast or the driver in the fixture. The source is the control device or the light switch. The 0 to 10 volt dimmer module takes one 20 amp line in from the circuit breaker, which is used to power the module. 8 low voltage outs are used to control each load. 8 relay outs are provided if external relays are used to control power for the fixture. The 0 to 10 volt dimmer functions with all protocols: 0 to 10, 1 to 10, 10 to 1, and 10 to 0. The module has 8 channel buttons which are accessible when the panel door is closed, each controlling their respective load. Pressing the button will send the load to the preset level. The button can be pressed and held to ramp that load up and down. And in a fault state, the button can be pressed and held to reset any fault. The channel LEDs indicate the on or off state, blue for on, black for off, or to indicate a fault state. If it lights up red, there is a short circuit on that channel. The module override button is accessible when the panel door is closed and functions as an override scene for the whole module. Once the loads are set to their desired levels, press and hold the module override button to save the module scene. Pressing that button will toggle the module scene. The module override LED lights up blue if the module is powered up or black if it's not, and indicates a fault state. The LED will light up red if the module itself is overheating. The link activity LED lights up green if the module is network connected, and orange if there is activity through the network to the module. There is a recessed reset button that can be pressed to reboot the module, or pressed and held to reset the module to the factory defaults. There is an auxiliary terminal which functions as a failover that does not require a Control4 controller, a router, or even a network connection. That auxiliary terminal is wired to a hidden, normal, dumb toggle light switch. That light switch can be hidden in a discrete area to give the end user access to the module seen in a failover scenario. And on the low voltage side of the module is the Ethernet port. Note that the V1 modules only have a single network in. The 8-port Ethernet switch. The 8-port Ethernet switch can run on 100 to 277 volts at 50 or 60 Hz and mounts in the same cabinet with the other modules. It also uses the same form factor to match the other modules. It features a standard 10-100 8-port Ethernet switch. It is not a gigabit switch, as the other Control4 centralized lighting modules do not require a gigabit connection. Using this Ethernet switch module simplifies the wiring, requires a single CAT cable to the cabinet, and a short patch cable from this to each of the other modules. The 8-port Ethernet switch accepts a 20 amp line in from the circuit breaker, has 8 activity LEDs indicating traffic for each port. If the LED is orange, that port is active. There is a recessed reset button that can be pressed to reboot the module, or pressed and held to reset the module to factory defaults. Terminal blocks. There are 3 different terminal blocks, one for the dimmer module, one for the relay module, and one for the 0 to 10 volt module. Notice that the terminal block for the dimmer module has 2 black connections, one for each of the 2 lines in. Notice that the relay module has 4 black connections, one for each of the 4 lines into the relay module. The terminal block is the connection point between the circuit breaker and the module. It gives the electrician a location to terminate during pre-construction. Without the terminal blocks, wire nuts would have to be used instead. The Control4 terminal blocks are similar to other manufacturers. Electricians who have done centralized lighting before will know what they are and how to install them. The terminal blocks are pre-configured, pre-assembled on the rail, and sold separately. They're generally purchased at the rough-in phase. The terminal blocks feature built-in jumpers between the line inside and the load side, and allows the loads to be turned on or off prior to the module being installed during construction. The terminal blocks also function as a breaker between the circuit breaker and the fixture, allowing the electrician to test for short circuits prior to inspection. Panels. The Control4 centralized lighting panels can be flush mounted between standard 16-inch or 40-centimeter stud bays. They can also be wall mounted if desired. They come in 2 sizes. The large is a 5-slot at 65 inches or 165 centimeters, and the small is 2 slots at 35 inches tall or 90 centimeters. The panels allow field wiring to be terminated at the terminal blocks during rough-in. Modules can be mounted and wired to the terminal blocks at the trim-out phase. The modules protrude through the panel door when it's closed, for easy access to the channel buttons and a clear view of the LEDs for status. The panels have spacing at the top and the bottom for wires and movement. There is a pivoting divider plate at the top and the bottom to separate the high voltage Class 1 on the left from the low voltage Class 2 on the right. The panels provide maximum use of knockouts for mounting and installation. The panels have tiebacks on the sides for cable management. This concludes Module 3.